Hi guys, welcome to the world of the chemistry again, and this time it is physical chemistry. Well, in this case we are going to take the very first topic of your syllabi, and that is your mole concept. Well, mole concept is always thought to be like it's a bit difficult one, or otherwise it would be a bit topic like kind of which is going to extend into details and details of calculations and everything. Okay. Now, the very first thing is that you need to cut out that fear of having it as a difficult topic. And secondly, we need to take a dive into it and like the topic like it has been like any other topic of chemistry. I hope chemistry is your favorite subject, or otherwise the one which can be like, okay. So let us move into this details of mole concept. So here I introduce you to, in fact, not introduce, but welcome you to the world of chemistry. This is your physical chemistry session starting with your mole concept. Well, mole concept is nothing about a particular measuring amount, okay, or otherwise I could say that it's a kind of weight, or otherwise I would say it's a kind of device or tool to measure something. Now measure what? Measure units. Units of what? So it would be the small tiny atoms, molecules, ions, electrons. That means I'm going to measure the so-called fundamental units. Okay, what I'm going to measure is the fundamental units. Now what does the fundamental units consist of? It consists of atoms, it consists of molecules, it consists of ions. So every other species which is contained in you, which is contained in me, okay, sorry, it was reverse, which is contained in me and which is contained in you, in every other species which exists on the universe, okay. And these fundamental units, as I told you, can be extendable to anything, my dear guys, okay. So it's not these complete ones, okay, but also the inner ones, okay. So I could say even the formula units can be your fundamental units. What do you mean by formula units is like that of the sodium chloride compound, the table salt which we take charge of. So it consists of a positive and a negative ion. So that is your Na plus and Cl minus. So again it brings back to the ionic level, okay. Well, this can go further to the electronic level also. So in this case, it's nothing but a tool to measure the amount of fundamental units. Okay, clear? So why does this word come into the picture when I could say that it's grams, it's kilograms or something like that? But it becomes a bit difficult. Why difficult? Why I'm using the word difficult is that supposedly if you have learned about the existence of an electron, existence of a proton, existence of a neutron, to sum it up, existence of an atom. Since your school levels, right? You know there was an experiment known as a cathode ray tube, right? And the details of which you are going to dive into this particular year, okay? But the very first thing is that you have been introduced to it, right? Okay, so you know that cathode ray tube stands as the best experiment to demonstrate the existence of all these three subatomic particles. Then in that case, if at all I was talking about say an electron, we know the mass of an electron, isn't it? Let us just write it down. The mass of an electron, isn't it? So let me just put it up over here. What I'm talking about is the mass of an electron, okay? And how much it comes out to be, you know? It's almost 9.1 into 10 raised to minus 31 kilograms. Oh my God. What if I was writing it, just keep this aside for some time, for some few seconds, and what if I was writing as 2 into 10 raised to minus 1, okay, minus 1 what, say kilograms, okay. So that is actually what, it's simply the shift of the decimal point on the other side, isn't it? So this is like 2 upon 10. Okay, so it can also be written as 0.2 kilograms, isn't it? What if I increase the power over here? What if I write it as 2 into 10 raised to minus 2? It would become 0.02. 2 into 10 raised to minus 3 would become in fact this is 31, sorry. So this is 3 only I wanted to say, okay. So that would be 1, 2 and 3. So that is 0.002. So imagine if it's 9.1 into 10 raised to minus 31. That means it is going to be your 30 zeros in a line, and after that 9. After that 1. Fine. So 30 zeros in a line. Okay. After that 1 kilograms. Oh my God. So can you imagine? It's such small. Fine. It is very, very small. And thus, to talk about such kind of things, we take up the fundamental unit, or otherwise, not fundamental unit, we take up the measuring device as mole. Fine. And thanks to Sir Amedeo Avogadro, who had devised this particular number by some calculations, which we would be getting into details of, okay. He devised this particular number of these fundamental units present in 1 mole of any of your atoms, any of your molecules, any of your units, okay, or any of your elements also in the periodic table. So in that case, this particular number given by Avogadro, this particular such kind of numbers to be exhibited, we took the help of Avogadro's number and we took the help of our SI units. SI units as in kilograms, grams, okay, and then tried to establish a relation between all of these so as to express the weight of these fundamental units, and that was nothing but mole. Got the point? Okay. So today we do have a very, very elaborative way to just express it, or a very simple way, yet elaborative, simple way to exhibit the measure or the number of the units contained in each of them, okay, in each of the quantities, whichever would be given. So it's quite simple, but the history is also very interesting to know. So the story starts right away with the substances which exist in nature, and that is the pure and the impure ones. The purest of all is your elements, okay. So the story starts right away with what? With elements, of course, okay. And elements consist of what? They consist of same kind of atoms. They consist of same kind of atoms. Fine. And these atoms, when they are going to combine together with the help of any of the bond formations, may it be the force of attraction which dwells in an ionic bond, or the force of attraction which dwells in a covalent bond. By any of the bond formations, it can give me the existence of two kinds of species. One would be molecules, okay, and the other one would be compounds. Fine. So in such cases, compounds and molecules could be distinguished in this way also, that molecules are going to have the combination of similar atoms, whereas compounds will be having dissimilar atoms coming together. So in that case, it could be like, it would be a fixed proportion which would combine and give me the existence of compounds, okay. Well, elements, if is a part of your pure substances in nature, what would be impure one? So the impure one would be nothing but the mixtures, okay. The mixtures of what? The mixtures of any substances in any of their states of matter. So may it be solid, liquid, gas, mixing up with solid, liquid, gas respectively, or interchanging them accordingly. So I can get 9 mixtures as such, with any 2 components being set into the molds, okay. So in that case, your mixtures can either ways be the homogeneous ones, okay, or the heterogeneous ones. Isn't it? Fine. So for all of them, may it be a molecule, may it be a compound, may it be a homogeneous mixture, heterogeneous mixture, or any other abnormal thing in this world, my mole stands behind them to express them, or to express their weight, okay, to express their quantity of existence in nature. Fine. So that is what is all about your mole, okay. Now, dating back to theories which we have already come across some or the other point of life, we know one thing is that we had a range of astrologers, a range of philosophers, okay, a range of scientists who had given the existence of the so-called atom, isn't it? An atom was known as the indestructible one, fine, which did not consist, which could not be divided further. So if I take supposedly this particular marker pen, I just go on breaking it up, fine. So I would be cutting it with a cutter and all, fine. So the last chunk of it which would be indivisible would be an atom, fine. So this was the idea which they had. So Sir John Dalton gave up his theory saying that your atoms, when they are going to combine together, okay, there exists a process or there exists a phenomena which is called as a reaction. Since it's atoms and there is chemistry involved in it, you call it as a chemical reaction. And this chemical reaction takes place not so very randomly, but it is in the measured way, okay. So supposedly, if I am talking about, say, water, it would always exist as 2 parts of hydrogen and 1 part of oxygen coming together, okay, participating and forming this particular molecule, okay. So in that case, what did he say was, H2O, as we can see, is made up of H2 and O2. So I could say maybe 1 part of H2, 1 part of H2 and half part of O2. To simplify this more, you could say it's like it can also be expressed as 2 parts of hydrogen and 1 part of oxygen. So that turns out to be like this. So this particular thing which I am putting in as coefficients is nothing but the part played by Dalton, okay. That was the balancing part. So as to say that the left hand side and the right hand side species will be the same weight, okay. And that weight can be expressed by mole, okay. So here goes in a kickstart to the mole concept in this way, okay. And furthermore, we would be getting into more and more details of it, fine. So welcome you all to this mole concept session. See you in the next session with some more details. Thank you for now.